Let's start in 2 minutes. Okay, let's start the class today. So I'm your lecturer this semester. My name is Seng, and you're calling Seng. Okay. Can I check what course are you guys in? All in the same course? AIT? Artificial intelligence. Okay, very good. Is it first year or second year? Second year. Okay, I think you guys know the rules very well because I'm only first year. Okay. So some administrative. Okay, first of all, I want to check who is not in the Moodle yet. Any one of you? Not in the Moodle? Okay, if you are not in the Moodle, right, please email me. My first name, last name, and at xmu.edu. Okay, email me with your student ID if you're not in the Moodle. And then, okay, so before we start the lecture, some administrative announcement. So mask must be on at all time. This is the uni policy. Also, I think there's a 10 minutes rule in this uni, right? So before 10 minutes, you have to arrive in the lecture hall before the class. Okay. And I will release you 10 minutes earlier. For 50 minutes, I will release you. Since this is a 3-hour lecture, so we will do 2-hour lecture and 1-hour tutorial. And every hour we will have a 10 minutes toilet break. Okay. Also, you need to reach 80% attendance to attend the final exam. Okay, if you can't attend the final exam, you will fail the course. I'll pass down the attendance sheet in the second hour later. Please remind me if I don't. What else? Okay, so this course will break into coursework and the final exam. So coursework will further break into quizzes and midterm. So these are 20%, 30%, and 50%. Since we don't have weekly assignment in this course, so we will have 5 quizzes. I've posted on the course information. You can see in the course information here. Okay. Yeah, the assessment. Okay, the first quizzes will happen in week 3. Okay, this is to check whether you understand the course content. And we will do quizzes in class during the tutorial, maybe 15 to 20 minutes at the start of the tutorial. Okay, so first quiz is on week 3. Yeah, also we need to fix a midterm time. So now tentatively we book week 8, 3 p.m. to 5 p.m. I think it's a Monday 7/11. Okay, good thing. 7/11. So you guys have any schedule clash on Monday? No? Still 3 or class? Okay. So will be 3 to 5 for now. I already confirmed with the other class. So I need to confirm furthermore tomorrow. If it's okay, then I have to book the venue first. Yeah. Okay. Also, for this course, there's a double pass through. So that means if you know that do you know this chart here? So you will fail the course if you are below 55. But even though if you get 55, if you don't get 40% on, you need to get 40%. Let me write down. So you need to get 40% on quizzes, midterm, and also 40%, at least 40% on final to pass. Okay. So you can't say that you don't do quizzes, you don't do midterm, and then you do very good in final, and then you pass. It's impossible. Okay. So you need to do 40% on quizzes, midterm, and then final to pass. Dictionaries are not allowed during the exam. I'm not sure you know the rules or not. Okay. Okay. Next thing is about office hour. My office hour. So here I wrote Wednesday 12 to 2 and Tuesday 12 to 2, which is after the class. But I got another choice is Tuesday uh 12 to 4. So which one you guys prefer? Any clashes with your class? First choice or second choice you prefer? Huh? First or both can? Hmm? Both can? Both can? Okay, then after this week I will decide after tomorrow classes. Okay, that's good. Then what else? So this one. And okay, this is the textbook we will use for this course. Okay. I already posted on Moodle, and that's a soft copy of it, non-distributed. Okay, this is for you. Okay. And then I got suggest some reading. There's a lot of example exercises you want to find. You can find from these books. And every week, so this period, first 15 or 20 minutes will turn into a Q&A section. So every week you can bring your own section here and then ask me. And then we will all discuss and then we will all benefit from it. Understand? Okay. So do your work and then bring your question if you don't understand. So you guys are last year September in tech, is it? Why last year don't have discriminate? It's okay. Okay. Just the order, okay? Okay. Um, any questions from you? Yeah.
This hour,
Yeah.
one, there's a group of our students will crash on the first field.
You mean this? Oh, okay. But you can still come here right, if I fix. Okay. Okay, okay. I will take note and then I'll decide in the end of this week. And then I'll make announcements. Oh, fixed hour start next week. Okay. If you see my Moodle announcement, in case you come into my office, I don't have. Okay. Okay, good. Anything to say? Nothing. Okay, so we will start the lecture today then. So some motivation, since you guys are studying AI, right? So now computer science, the trend now should be AI, machine learning. Okay, so machine learning, AI, they all uses the language of mathematics. So in this courses, we will learn the language of mathematics. So it may be different from what you have seen mathematics before. Okay, maybe what you've seen before is just arithmetic, but now we are learning the proper language of mathematics. Okay, maybe you'll see more words now. So in this course, we will touch on set theory, logic set theory. This is what you use to what you use in the language of coding. And actually, the trend now is to, this is a new trend, but it's not touches on this course. Just tell you that the new trend now, they will use something called category theory. Okay, this has more structure than set. Okay, they also study the function between set. Um, um, yeah. So the style of this class is, first I'll give definitions. And then I'll give examples to help you understand the definition, and then we'll see the application. Okay, so whenever I define something, if you don't understand, you should ask me for definition. No, ask me for examples if I didn't give you. Okay. So basically in this course, we have logic, set theory, number theory, so number theory, and a bit of cryptography, not cryptocurrency, but cryptocurrency is encrypted using some cryptography method. 4 is combinatorics, so how you count. 5, wait, 1, 2, 3, so 1, 2, 3, 4, 5. So 5 is relations meaning function. Okay, the thing you learn in the high school, FX. Okay, but we will make precise what it means. It's not just graph. Okay. 6, graph theory. So graph theory is something like linking the nodes, something like that. 7 is Boolean algebra. Okay. Any question? No? So first 3 weeks we will dwell on the logic first. Okay. Okay. We'll start the first lecture now. So start with logic. You don't need to copy everything what I say because I will post it out after tomorrow classes. And yeah. So just listen to what I say and then understand what I say. If you don't understand, you should ask. Okay, just raise your hand and ask. Okay, so first logic. So we start with propositional logic. Okay, first thing first, I want to define what is a sentence is. Okay, a sentence is a complete statement formed according to the rules of grammar and communicating a meaningful talk. Okay, so example, Okay, so question first example, is this a sentence? Why? Hmm? Why? Why? Okay, very good. The grammar is wrong. So this is not a sentence. How about second one? Is this a sentence? Why is it not a sentence? Huh? It's a sentence, right? Who are you? How about the third one?
Yes.
Okay, this is also a sentence. How about the fourth one? Okay, this is a proper sentence. Okay, good. Okay, good. Let me make another definition. So I only want to look at this particular sentence called proposition. So what's the proposition? So a proposition or a statement, sometimes I will use statement, sometimes I use proposition. Okay. It's a sentence. First of all, it is a sentence, so I must obey the rule of grammar, and then there's some meaningful thought that is true or false, but not both. So in mathematics, we are interested in statement which can be said is true or false, but not both. Okay, we don't want to look at some sentence that's both true and false. It's meaningless. Okay, so check again. So first, this is a non-example. So since this is not a sentence, it is not a proposition already. How about second one? Is this a proposition? No, right? Because you can't say it's true or false. Why you? It's a question. Okay. How about third one? Yes. Okay. It is a proposition and it is true. Okay. Four, but false. Why is it false? Why? For example, 10 million. Okay, good. Yes. So whenever you say something is false, you need to give me a counter example. Okay. So this is a proof method which we will touch on later. So to prove that something is wrong, so you want to prove someone is wrong, you need to give an example. Okay, for example, what's your name? What's your name? Hello, what's your name? Wei Chen, huh? Okay, Wei Chen said 10 million. Okay, see, 10 million is greater than 1 and also greater than 1 million. Okay, good. So now you prove the guy wrong. Okay, you found counter example. So if you want to say someone is wrong, then you need to give an example to that guy. Okay. Okay. Okay, very good. Any question? No question? Please ask question and don't be shy. Don't come after class. Okay. So this true and false we call the truth value. So the truth value of a proposition is true if the proposition is true. And of course it's false and if the proposition is false. Okay. So the true and false are called the truth value. Okay. Okay. So some notation. So this we will use small letter, usually P, Q, R, S, to denote different proposition. And usually we'll use capital letter E for true, and then F for false. Okay. So since we have so many propositions in the world, we can build new proposition using the old propositions. Okay. So these propositions are called the compound propositions. Okay. A compound proposition. So what's the compound proposition? First of all, it is a proposition. Okay. Okay, first of all, it is a proposition formed by using the existing propositions using negation and all. Okay. When I write down this question, actually, I haven't defined what negation is and is or is. Right. But I will do it later. Now, I mean soon. Okay. So whenever you read this kind of definition in the books, you should ask yourself when the definition talk about these nouns, what it means. Okay. So when I define compound proposition, it says that a compound proposition is a proposition. So you should ask yourself, what is a proposition? So you need to go back and find, so what is proposition? A proposition is a sentence that is true or false, but not both. And then you see another noun here. What is sentence? So you should go back again. What is sentence? So this is how you read these definition. Yeah. But of course, you can ask me what is statement, but we have to start somewhere. So I choose to start with this statement here, English word. Okay. So next, I said that proposition form you from existing propositions using negation and all. This two and is different. Okay, I will define this and later. So now we were going to define this three word: negation and all. Okay, so let's try definition. So let P be a proposition. So we got a proposition called P. Now this is what it means. So we want to negate P. So the negation of P. Okay. And then we will typically write it as not P. Okay, not P, like this. So what is it? It's the statement. It's the statement or proposition, if you like. It's a statement. It is. It is not the case that P. Okay. So examples. I'll give you an example. Let me copy this to here. So let me copy this to statement here. Maybe I go to the other page. Okay, so example, let P equals to this. And then let Q, this example, second, let Q. Okay, for example, first example, let P equal to the Xiamen University is located in Sepang. So what is not P? Okay, that one is very good, but already skip one step. Okay, I'll write it down here first. So S is not Okay. Okay. So I think this is good, but to follow this definition here, first of all, it is not the case that Seng University is located in Sepang. Okay. Although it's not wrong from the other from although this okay, let me write it down first. And then I say it is not the case that okay, this is not wrong, but this is the process. Okay, so you go from here and then go from here, go to here. Okay, try not to skip step. This is the when you do the coding, right? Sometimes you need to do the debugging. Maybe sometimes you can skip and don't know what's going on. Okay, any question on this example? No? No, and then we will try to do the next one. So Q is every number greater than 1 is less than 1 million. So what's not Q? Okay, good. It is not the things that just copy. Okay. Okay, there's another way to say it. So the other way to say it is there exists a number greater than 1, but is greater than or equal to 1 million. Okay, this is something this is called the quantifier, and we will touch on it in the later weeks. Maybe next week we'll come back to this kind of example again. Any question? No question. Okay, next. Oh, okay. Actually, one thing to see here. So if you notice that when P is true, not P would be always false, right? And also similarly, if P is false, then not P is true. Okay. This is what you observe. Okay. So we will make it precise now. So okay. So we call this not P, not P. So we'll write down the true value of the statement of negation. Okay. So the true value of the negation of P. Yeah, maybe I want to write here. Not P of P is the oh, hello. Morning. Good morning. Okay. Opposite of the true value of P. Okay. So sometimes we will use different notation. So maybe I put notation again. Notation. So sometimes we'll write minus P or a curly P. Okay. If you see both of these in the literature, they are all no P. Okay. So the next one. So in this case, we can form a table called truth table. So this table will be consisting of all the possibility of the true value that the proposition can take. For the new student that just come in, are you in the Moodle already? Okay. Okay, for example, what do I mean by a truth table? P and not P. So P, there's two possibilities. Either it is true, either it is false. Okay, there's only two possibilities. This is the definition, right? Proposition is a sentence that is true or false, but not both. So two possibilities. Either it is true, it is false. Okay. Then you can fill the truth values for not P. So if P is true, then not P is false. If P is false, not P is true. Okay, this is also based on this definition here. Okay, everything have to be based on definition. Okay, next. Okay, good. Next, we will go into ends. So what is ends? So in the ordinary speech, when you talk to other person, you also will use and or to connect sentences, right? Similarly in logic. So definition. So let's given two proposition. For and we call it conjunction. Conjunction. Okay, conjunction of P and Q denoted by P hat Q. Okay, what is the conjunction of P and Q? First of all, it is a proposition. Okay, so I can say it is true or false. What is the proposition? The proposition is P and Q. Okay, maybe sound a bit, but okay. So when is it true? So this is my definition. So conjunction P hat Q or P and Q is true only when both. Yeah. Well, who do homework already? Who know? P and Q are true. Okay. And is false otherwise. Example. Okay. So see this table here. Okay. Let's see. So, okay, and then the truth table is today the iPad is not. So P, Q, P, and Q. So we have true, true, and then the true, false, and then the false, true, and then true, true. Sorry, false, false. So typically you will have like two times two possibilities. So if you have more, then you times two again. Then so P and Q is true only when both of them are true. So only here is true. Okay, the other should be false. Okay, for example, okay, give you an example. So first of all, let P the durian is spiky maybe. Then Q the vinegar is sweet. Okay, so P and Q is true or false?
Oh,
False. Why?
Q is false. So it can't reach the point.
Okay, so Q because Q is false, although P is true. Okay, so one false, the whole statement false. Okay, any question? No, very clear. Okay, okay, good. Move on. Okay, maybe just copy everything there. Copy everything. Okay, the next thing in the series is all. Okay, we'll define what is all. What is all? All. 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 Okay. So we define what is all. Okay. So P and Q be similarly. We have two propositions. We want to introduce all, which is called the disjunction. Okay. So disjunction, we will write this notation here, inverted hat, and then it is called P or Q, and then the disjunction. Okay, what's the truth value here? So P or Q is false when both P and Q are false. Otherwise, it is true. Okay, so for example, P true, Q true, P or Q true or false? True. P true, Q false, P or Q true or false? True. P false, Q true, P or Q true. P false, Q false. Okay, so if it is all, either one is correct, then it's true. Either one is true. I don't want to use correct. Either one is true, then the statement is true. Okay, for example, the same running example. So P or Q is true or false? True? True. Okay, true. Because we know that the durian is okay. Okay, there's another example. So 2. P is tall or short. True or false? False? Huh? False. No, what? Why is it not a proposition? Huh? Hard to define. Isn't it one person either is tall or short? And sure both. Didn't define what? Didn't define tall and short. Huh? Okay, okay. I think this is a good spirit. But okay, let's say I have a assumption. Okay. I think you are right. You are in the right track into the computer science or mathematician. Okay. So assumption. So assumption. One person is either tall or short. Okay, I already fixed. In this world, the one every person, okay, every person is either tall or short. Okay. So I reach you, you're tall. Reach you, you're short. Reach you, you're tall, you're short, you're tall, you're short. Okay. So in this case, he is tall or short is true or false. True, right? So he is either true or false. I don't mean true or false. Either tall or short. Okay. Even though it's tall, it's not short, but it's still tall. Tall is true. Okay. Okay. How about this one? Uh, bonus question. He is tall and short. True or false? Why? Say again. They cannot be tall and short at the same time. Okay. So if it is tall, then it's not short. If it's not short, then this is false. Okay. True or false. And if it is short, then it is not tall. So tall is false. Okay. So you need to argue every possibility. Any question? No, no question. Okay, several more minutes. Then we keep going. Keep going. So okay. So actually, you didn't realize that in English, actually, there's two or. There's two kind of or in your ordinary speech. So the disjunction we call it just now, P or Q. P or Q is actually called the inclusive or. Okay, because when they are both true, it is also true. Okay. And then the next one I want to introduce is actually XOR. So it's called let me just copy this. Okay, never mind. I'll do it again. So let E and Q be propositions again. The exclusive or of P and Q denoted by P or plus Q is the proposition P P X or Q. Okay, P X or Q. So when is it true? So the exclusive or P or plus Q is true when exactly one of them is true. Only one of them can be true, but not both. P and Q is true and is false otherwise. Okay, now I copy the table. Okay. So in this case, what is if P is true, Q is true, P X or Q is what? False. True, false? True. False, true? False, false? Okay. Then you might think, what is it for? Why should we have this kind of explicit one, right? Yeah, so why? How is it useful? Okay, so let's say uh, you think about what to eat tonight, right? You maybe you have chicken rice in D6, or you have the economic rice also in D6. So which one you want to choose? You only can eat one, right? So you could have the chicken rice or the economic rice, or sorry, I wrong, for your dinner in D6. So you can't eat both, otherwise you'll be too full. Okay. Also, there's another example. I will use all my bonuses to either buy an unit in Belgium or buy a vessel. Okay. So when you don't have enough to do both, then when both are true. Okay. Any question? Any question? No? No? Any question? Okay. Maybe we have a break and then we'll come back at 10. Yeah.
Can you turn off the activation?
Turn off.
Turn off.
Turn off.
Like warmer.
Oh.
The temperature of air conditioner.
Yeah. We can go back.
而且昨天那个是就是办会时间，然后是会开始的时间比准备的时间还长，所以看这个。
你喜欢这里？要配的话，没太太大。
Yeah. Okay. For the lecture notes online, if you see pause the lecture notes, I already paused the previous year one. Sometimes I didn't follow entirely inside the lecture notes, so I will post what I done in the class after the lecture, which is after tomorrow because there's one more class tomorrow. And I also will post tutorial question beforehand every week. So it's a question from the textbook mainly. If I found something else, I will type it out. So ideally, you should try the question yourself, not necessarily finish it, at least look through it. And then the first maybe 15 minutes you will discuss among your friends in the class, and then after that we will discuss together. And if there's a quiz on that week, then the discussion in the tutorial time, the first 15 minutes or 20 minutes will become a quiz time. Okay, and I will pass this to the attendance list down, and then you should sign it. And then please take good care of it because I need to keep it for 15 minutes. Otherwise, there's no evidence for you to be here. And if you can't attend the lecture or absent, you should tell me yourself, okay? Email me. Don't help your friend to sign, okay? Ask your friend to email me. Only sign for yourself. Okay. Okay, next. Okay, next. Is it going too fast or not? Or too slow? Okay. 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 That's fine. So let P and Q be proposition again. We want to introduce a new thing called the conditional statement, which is P implies Q. Or sometimes we will call it if P then Q. If P happens, then Q will happen. Okay. So when is it true? So maybe just say when it is false, it's faster. So there's only one place it can be false. So this conditional statement is false when P is true, but Q is false. Okay. And true otherwise. Okay, let's check the truth table. Why my today not good? Maybe when you study AI, right, build a better iPad. Build a better iPad, you know? No, okay. Now you see the I think the sign is like stagnant now. So when you see the new iPhone, new iPad, there's no new update actually. So yeah, the future is on you guys, okay? Maybe build a already. Yeah. But you just come or you just come back from the rest? Oh, okay. I thought you missed the whole hour. Okay. Okay, sorry, I have to live with this not straight line, curly line. This is crazy. Okay, P, Q, P implies Q. So you got true, 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 false, false, true, false, false. So true implies true is true. True implies false, false. False implies true, false implies false, true. Okay. So what this means, so let's examine this truth table here. So true implies true. This statement can be true. But a true statement implies a false statement is always false. Okay? So the true thing cannot give a false thing a true. It's always false. As long as your Q is false. So as long as what you say in the end is false, then it's false. Okay? Okay. Okay. So I thought I want to give you an example. So like if your boyfriend or girlfriend say I will promise something to you, and then he said I love you. Actually, if he doesn't love you, then whatever he do is false. Okay, no matter what he promise or she promise you. Okay. Okay. The next one, false implies true is true. So no matter what, whether P is false, as long as Q is true, it's always true. Okay, so this means if you say something imply something will happen, but Q will always happen, doesn't mean that P will happen as well. You get what I mean? Okay, I said slower. So P implies Q. So imagine Q happen. And then you said this statement here. This statement is always true. Okay, this is happen and true. So it doesn't mean that not necessarily P is true. Okay, so you can't deduce anything. You know what I mean? You get what I mean? Not really. So okay, come back again, okay? So false implies true is true. Okay. So that means false wrong stuff can imply everything. Who say one? Who say one? Oh, you say one. Okay. I shouldn't say can imply everything. So if you say something that's true, false implies true is still true. So it says that even though you know that this is true, you can't deduce anything from here. You get what I mean? Okay. Put it in other words, you know that Q is true, you can't deduce P. You can't deduce P is true or false. You cannot go backward. Okay, this is what I want to say. You see. Okay. You see, this is true, but both can be true and false. Okay, so you can't deduce anything if you know that Q is true. This is frequently happen in our proof writing. So I'm trained in the pure maths. So for me, teaching in computer science is also new. So I'm also learning. So in pure maths, this is very important. So if we want to prove that if something, then something, we want to use this property to prove here. We're not actually we don't sure that whether this will imply this or not. Okay, this maybe false or true. Yeah. Okay, this is important in the proof writing. Okay, and then false implies false is true. That's it. Let me see. So let's try give an example. Give an example. Okay. Okay, if an example. If it rains today, then this an event is located in the park. Okay. So this statement is true or false? Why? Oh, true. I'm here. Why is it true?
Either it rains or not, that's an place for people.
Yes, that's right. I don't care if it rains or not. Okay, so it's true because regardless. Or not. Okay. Okay, good. Second example. So I claim if it rains today, then I will bring an umbrella. Okay, so the question is when is this statement true? So when is this statement true? And
Bring her number.
okay. Anything else?
I would
Isn't if it don't rain, I don't bring umbrella also true. Okay, good. Anything else? Good. Louder. Louder. Yes, correct. As long as you bring umbrella, you're true. If you don't bring, then it must not rain. Okay. So there's three ways for it to be true. Okay. Any question? No question? Any questions? Okay, we proceed. So there's few way to see to say if then. So you should know this. This might be common in the test. So if P then Q. Okay. So usually sometimes we write if P then Q. Q happen. Or Q if P. Q happen if P happen. And always you will hear me saying that P implies Q. Because usually there's some connection between P and Q. So we can go from P to Q. This is usually the case when we say P implies Q. P only if Q. Okay. Or P is a sufficient condition for Q. So P is sufficient for Q to happen. Although Q might happen itself. Or Q is a necessary condition for P. So if P happen, Q must happen. Q must happen. It's necessary to happen if P happens. And then Q provided that P. Or you use Q whenever. Okay. Yeah, these are the few common ways to say if P then Q. Okay. Cool. Next. So next we want to introduce three different propositions. One is called the converse. Okay. The converse of P implies Q is the proposition Q implies P. Okay, here I want to warn you that this P and Q I can easily change to R and S and then T, U, V, W, X, anything. But the key here is to observe the relative position. Okay, so now the converse of P to Q is the proposition Q implies P. So you swap the two propositions. So if I write R to X, then it's X to R. Okay. So in mathematics, we are like interested in all these combinations. The pattern change. And the next one is called the contrapositive. It's quite important for you, maybe also for me. So the contrapositive, if you swap and then you negate both. Okay. So you swap and then you negate both. Okay. So P, the contrapositive of P implies Q is not Q implies not P. Okay, you swap. And why is this very important? Because these two is actually logically equivalent. Logically equivalent. Okay. Later we will see what is logically equivalent. Basically, when you want to say P implies Q, actually you can see whether not Q implies not P is true or not. Okay. Yeah. Okay. So the inverse of P, the third one is the inverse called the inverse. The inverse of P implies Q is the proposition not P implies not Q. So you just put not on both. Okay, so this inverse is actually quite interesting. So in pure maths, there's a thing called a group theory. So we also have an inverse. Oh, actually, inverse appear in your fraction in a rational number. So fractional. So for example, 2 times the inverse of 2 is 1. or 2 times 2 inverses 1, right? So why? So you wonder why is this called inverse? Okay, let's see. So you apply inverse to this P implies Q, you get, what do you get? What do you get? What's the inverse of P implies Q? Not P implies Q. So you go back to the definition. Okay, the inverse of P implies Q is not P implies not Q, right? Okay, you do it again. So not P implies not Q. What do you get? P implies Q. So not P become P again. Not this. So you see, you go back to yourself. Okay. You do nothing. Okay. Yeah. Okay. Okay, maybe you ask like why this is 1. Because 1, everything times 1 is itself. So it's the identity. We call it identity. Okay. Any question? Do you want example on these? Do you want example or not? Yes? Yes. Okay. Yes, please. Okay. Let's try this then. Let's try this. Okay. Let's try this. So what is the converse of R? What's the converse of R? If what? Okay, one of your shot. Huh? Okay. Yes. But then so so first thing you do is you want to okay. So when I ask the converse of R, so you should go back to see the definition. What is the converse of R? So R have to be in this form, P implies Q. So that means you have to be able to break your sentence into P and Q. Okay, so here is the P, here is the Q. Okay, and then it says that it's the proposition Q implies P. So it's if SMUN is located in span, then it runs to that. Okay, make sense? Make sense? Okay. So okay, good. Maybe tell me what's the definition of contrapositive first. Not Q implies not P. So in this case, what do you have? If okay, it is not located in span, then it doesn't have to. Okay. How about inverse? So the definition of inverse is what? Remember? Not P implies not Q, correct? Not P implies not Q. So what do you get? If it doesn't, Yes, that's right. Okay, good. Next. Okay, the last one is called the just move this. Okay, now I want to introduce the double-headed arrow. So this is called bi-conditional statement, and then it is a double arrow. So this is called the if, and only if Q. Okay, this is called a biconditional. Okay, so when is it true? So the true value for this biconditional statement, P if and only if Q, is true. Is true when P and Q have the same true value. And is false otherwise. Okay, so true is true P and true false P if and only if Q is true. True P and false Q false. False P and Q true false. False P and false Q true. Okay, so this is like combine the converse. Okay, so you have this and this, the converse. Okay, because in real world or especially in mathematics, once we prove that P implies Q, there's a method to go from here to here. We will naturally ask, is the converse true? So can we go backward or not? Okay. If we can go here and then go back again, this would be called the equivalence. So we create a bridge between these two. We can go back and come back, go there, come back. Okay. But of course, sometimes it's not true. You can only go one way. But sometimes you can go both ways. So this is the if and only if. Okay. Yeah. Any questions? Any questions? No. Definition, not definition. Maybe I just do some remark here. So the negation, the N, the O, the XO, maybe include the if, then there are few ways to say it differently. And also if and only if. Sometimes these are called the logical operator. Some book only include up to XOR, but some book include all of them. But never mind, we just say that they are under the category of logical operators. And sometimes they will call these two, maybe these three as the connective. So you connect few sentences. Okay. Any question? No? Okay. So next we will turn this language into some binary digit. So a bit closer to the computer science. So turning into the binary from loading. Okay. Okay, definition. A bit is a symbol with two possible values, namely 0 and 1. So now the computer or laptop machine, they are built out of 0, 1. If you go see some videos like the 0, 1 keep running. So these are called the binary digit. So binary digit, so they take the first I and T and bit. And actually in the fourth frontier now, there are research on something called the qubit. So what's a qubit? Qubit is a quantum bit. Right? So why quantum bit is faster? It's like the quantum computer, if you heard of it. You can search on YouTube, I think there's a lot. Or the supercomputer. Supercomputer maybe not, but quantum computer is. So quantum bit can take out digits from 1 to 9. So I can process more things at once. So it is very fast. Okay. But it's still under research. Okay. Yeah. Okay. Come back to this topic here, binary digit. So usually the convention is 0 represent false, 1 represent true. Okay. So through this false and true, we also can draw a similar truth table. Okay, for example. Okay, for example. I want to read again. Okay, for example. P, Q, P, and Q. True, 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 false, false, true, false, false. Okay, so 1, 1, P and Q is what? Huh? 1, 2, 2, 2, or 1, 0, 0, 0, 1, 0, 0, 0, 0, 0. Okay, false, false. Okay, good. Very good, very good. So, okay, so through this convention, wait. This convention. We also have a not or and XOR. Okay, to represent the previous logical equivalent. To represent the not, the or, the and, and the XOR. Okay. Okay. Any question? No? Any question? Okay. If now we make a new definition. So we have a bit string. So what's a bit string? A bit string is a sequence of 0 or more bits. Okay, so what does this mean? So first of all, it is a sequence. Sequence of what? 0 or more bits. So what is bits? Bits is a symbol that with two possible values, namely 0 and 1. So you could have nothing, empty bit, or you could have like 0 or 1. Okay, this is example I write here. So maybe you can have 0, 1, 1, 0, 1, 1, 0, 0, 1, 0, 0, 0, 0, 0, 1, or 1, 1, 1, 1, 1, 1, 1, 0, 1, 0. Okay, these are all bit string. Okay. Any question? No question. So definition, the length of this string, wait, the length of this string is the number of bits in the string. Okay, for example, what's the length of the empty string? 0, 0, 1, 1, 1, 1, 0, 1, 2, 1, 0, 2. Next, next, next. 7. Okay, fast. Okay, next. Huh?
11.
Okay. Yeah, 11. Okay. Okay. Not sleeping. Okay. Okay, good. Okay. Next. Okay. So next definition. So we want to be able to add more bits. So we want to add the bits with same length. Okay. So we call it a bitwise OR, also bitwise AND, also a bitwise XOR. Okay. Of two string. So that must be of the same length. Okay. You only can add same length. Is the string that has the following in corresponding B in two string. Okay, example. For example, let's do some calculation in this math class. So let's do bitwise. Oh, so what does this mean? So go back and check your definition. So what does the definition say? So first of all, you need to add same length, string of same length. Okay, so are they the same length? Yes, length of 4. And then add them bit by bit, corresponding bit. Okay, so all, you need to take all. So 1, 0, what do you get? 0, 1, 0, 1, 1, 0. Okay, maybe I add more. 1, 1, 1, 1, 0. Okay, 1, 1, 0. 1 or 1? 1, right? True or true? 0, 0,
0.
0, 0, 0. False or false? Yeah. Okay. Okay, let's try another one. Bitwise and bitwise and what do you get? 0, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0. Okay, good. Okay, very good. Bitwise. This one harder, I think. 1, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0. Okay, 0, 0, what do you get? 1, 1, 1, 0, 0, 1, 0, 1, 1, 0. Okay. Okay, easy, right? Very easy, is it? Too easy. Okay, next. Next. Too easy, someone want to sleep already. Okay. Okay, next time I will prepare something harder, okay? Okay. Just kidding. A logic circuit receives. Is the class too early, 9 o'clock or not? To you guys? Yes?
Yeah.
Oh yes, okay. Uh you can in the class maybe you can how to say sleep. No, you cannot sleep. You can do something to make sure you don't sleep. But don't disturb the others. Okay. Maybe you can bring some sweet or something like that. Okay. But don't disturb the others. Okay. You can sleep. What's the earliest class in this uni? 8. Okay. That's worse than. How about the latest class? What time the classes end? The latest one. 8? 9? 9. So 9 you have to come to the class here. Like stay up till until 9 o'clock. That's late. Yeah, I'm not sure whether it's not enough classroom or what. I'm not sure why they put until so late. But in my university last time, I think we have class earliest also 8. But I think we finished all the classes before 6 or 7, 6 I think. Yeah. So I think 9 is quite late. Okay, continue. So a logic circuit receives input signal. Okay, this proposition. Oh no, okay, actually not proposition, the 1 0 thing, the bit. And then here the bit produce other bits. Okay. So for example, okay, this example should keep in mind. Maybe I can have a question in this kind of form. So So I think maybe you see this in some physics classes before. So this is called the NOT gate, okay, or the inverter. So if you input a P, you get a NOT P. Very good. So the next one I want to introduce is O gate. The O gate, O gate, gate, O gate. Okay. So O gate, when you input P and Q, you get P or Q. So you get the next one is the N gate. So you input P, Q, you get P and Q. Okay, this one will be what's this? Okay. Okay. What time is it? 10 more minutes. So do some more things. Okay, we will touch a bit on logical equivalence today. So any question up to now? Proposition logic, or you have some example that you want to discuss? Maybe you can think of some interesting proposition, then we can discuss whether it's a true or false. Okay, next. Next, we will introduce proposition which is called the tautology. Again, what's the tautology? Tautology is, first of all, a compound proposition. Okay, that is always true. Maybe someone like this a lot. Okay, no matter what, true. It's the variables. Yeah. Okay, I think just now we have encountered a tautology, which is, if you still remember, we said something about P is for short. Okay. So, of course, we said that assumption is every one is either for or short. Okay, actually, to be precise, like what your classmate said just now, we also have to define what is tall and short. So we don't need to know about tall, maybe we have to say about short. So short is not tall. Okay? So this is a tautology. So no matter what happens, is true. Okay? Right? We discussed already just now. Is tall or short is true. Always true. Right? Okay. Definition, next definition. A contradiction. So contradiction is the opposite thing. It's also a compound proposition that is always false. Okay, it's always false. We also encountered this already. E.g., the same running example is tall and short. Contradict mine, right? You say you're tall but you're short. You say you're short but you're tall. They're contradicting. Contradict yourself. Okay, so exercise. Use truth table to show that P or not P is a tautology and P and not P is a contradiction. So in general, P or not P is a tautology and P and not P is a contradiction. This is in general. You can prove this using truth table. You want me to show it? Huh? No? You know how to do? You know how to do? You know how to do? No? You don't know how to do? You don't want me to show it? Okay. Want me to show you or not? Huh? Okay, okay. Let's try. So that, okay, this is one kind of a proof question in this logic course, okay? So I will teach you how to analyze this question. And then for the other thing, you need to try to do yourself. Oh, about the lecture notes online, right? There might be some content that I won't touch in this course. So if you are interested on those topics, you should study it because I don't cover in this course is because they are applied. So that's mean after you learn this, you go and read those, you will understand. But if you don't understand, if you are interested, you can ask me. Because in the university, the way of learning is not like I have to teach everything, right? So because even for me doing research, we also might read something that's not in my research field. So it's okay for you to just go and read those things, and then you can come and ask me. Okay. So in this course, we will cover the essential definition for you to ready to understand the whole field. Okay. 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 Prove that P or not P is a tautology. So first of all, you already know this very well, right? P or not P. But what's a tautology? Okay. So you need to go back and find the definition of tautology. So tautology says that it's a compound proposition that is always true. So try build this truth table here. Okay, the truth table is here. P, not P, P or not P. Okay, so it's a compound proposition that is always true. So there's only true value can appear here. Okay, this is what you need to show. So for P, there are two possibilities, right? Either it is true or it is false. So when P is true, not P is false. This is 1 hour ago. So for P is false, not P is true. So P or not P. So true or false is true. False or true is true. So there's only true value here. So this is a tautology. Okay. Okay. How about contradiction? Maybe we try the contradiction. I'm not doing the word, but you do. Then we will take a rest, take a break after the contradiction. And next to the contradiction. So I said that P and not P is contradiction. So first of all, what's the definition of contradiction? Always false, right? So this column here must be always false. Okay. So let's try. T and true and false, what do you get? False. False and true? False. Okay, so it's always false. So this is a contradiction. Okay. So yeah. So what you did here is like you check all the possible cases. It always contradict each other, so it's a false. So in general, these contradiction in tautology maybe include more variable here, but it's the same way of listing down and then check that the compound statement is all false or all true. Okay, any question? No? No questions? Yep. Yes. Oh, when do you use the 1-0? So true and false usually used for the propositional logic. So it's like a statement logic. But 0 and 1 sometimes is used in a different language we call the Boolean algebra. But the thing that why not encouraging using 0 and 1 in this class is because there might be a different convention saying that 0 is true, 1 is false, maybe different convention, but depend on the convention. But usually I practice this. So if you want to use 0 and 1, you can use this way. Because if you use this, then I'm not sure later maybe I mark it wrong, then you come and complain. So better that you just use true and false, then it's clear. So in real world, maybe real world, yeah, real world, you also need to check what's their convention first. Okay, so but true and false is immediate. But 0, 1, maybe not. Any more questions? Any more questions? No more questions? So you guys already have the access to the tutorial question already, right? Already on the Moodle? Have you seen? I posted the question, and then I also have posted the textbook PDF. Okay, so we will take a rest and then come back after 10 minutes. Yeah, all done. Okay, thank you. I can't. Not the name. Right. Right below. Then you look email. Are you in the not in the video? Can you email me? Do you understand what I'm saying? Okay. All right. So we'll start the tutorial now. You can discuss among 4 of you or 2 of you, 3 of you. We will discuss, come back and discuss together at 11:20. Yeah. Yeah. But yeah. Discuss all this question here.
And what's the rest?
Are you asking like how to extend this or what to say? How you want to use that one? Okay, I think we should start. Okay. Hello. Okay. So I think most of you, some of you have finished already. So we should start now. Okay. So which these are proposition? Maybe we start with that row. So then one by one go back. Okay. So do not pass go. Is it the proposition? No. Why? Please listen to your friend. Okay. It's a instruction. Okay, good. It's a command. Okay, next. What time is it? Why? Okay, it is a question. It's not like a question. It is a question. Okay. There are no black flies in my knee. Huh? Yes, it's a proposition. So if it is a proposition, it's true or false? Okay, it's either true or false. Okay. So if I assume there are black flies everywhere, so if then it is false. Okay. Very good, very good. Okay, you guys are in the process to become a computer engineer. Next, 4 plus x equal to 5. Yes or no? Huh? Why? Huh? Because x can be. Okay, because right. Let me color it. No, because can be both true or false. If x equals to 1, then this statement is true. If x equal to 2, false, because 5 is not equal to 6. Okay, actually, to be proper, we should introduce what is 4, what is 5 first before we talk about this question. So in a proper foundation of maths, we will talk about what is 1, what is 2, what is 3, and then what is 1 plus 1. Okay. But anyway, in this course, we just assume you know already. So E, the moon is made of green cheese. Is it a proposition? Yes? Yes, of anyone? Yes, why? Why is it a proposition? Huh? Can you speak louder? It's a sentence, okay, and then louder. It's a sentence also, and also what? And also false. And also false. Okay, so it is a sentence, and then it can be false, can be true or false, but not both. And then the true value of this sentence is false. But why? How do you know it's false? You went to the moon. Ah. Okay, maybe it's not green cheese. Maybe it's white cheese. Okay. Not sure. Okay, next. So 2 to the power n is greater or equal to 100. True or false? I don't know. Yes, it's a proposition or not. Why? It's either true or false. So when is it true? When is it true? When n equal to? Huh? Other can answer. 7? So n equals 7, 2 to the power 7 is what? Huh? 1? 1 to 8? 1 to 8. So it's greater than 100. Okay. So this is the first n that is true, is it? Yeah. Okay. Next. Next. Maybe just let me see. 1, 2, 3. Okay. Just continue first. Okay. So Janice has more Facebook friends than Yuan. So what's the negation? Next. Who is the next one? Okay. Janice has less friend than Jessup. Okay. But they, if it is equal, then also it is false, right? So it has to be less than or equal to. Who more than? Huh? Yeah. 4n. Uh-huh. Uh-huh. So if it is not more than, it is what? Less than or equal to. They can have equal friend, right? Equal many. You get what I mean? So you see, okay. So like Janice has more than both J. So it can be like greater or equal to. Okay. They can have same number of friends. Okay, next. Quincy is smarter than Venkat. Next. Is what? Wait. Quincy is not stupid then. Okay. Wait. I don't think Quincy is not stupid. Wait, what is new stupid? It's the same thing. Wait, it's not stupid, huh? It's more stupid. It's more stupid. Oh, okay, okay. It's more stupid. And maybe no. It can be more stupid or equal stupid. Okay. Equal stupid also can. But okay, but I prefer not to say stupid. Okay, just say Quincy is not smarter than Bangkok. Okay. Okay, next. Zelda drives more miles to school than Paula. Does not drive more miles. Okay, correct. Does not drive more miles to school than. Brianna sleeps longer than Gloria. Next. Okay, good, very good. This is the very standard answer. And then the other answer you could have is Brianna sleep less than or equal to Gloria. Or you could have Gloria sleeps longer or equal to Brianna. Okay? All these no question? No question. We go to the next one. Okay, we start with a new row, this row, second row. So P, I bought a lottery ticket this week. I won the $1 million jackpot. And not P. Why is not P? Louder? Okay, can you hear from the back? From the back, can you hear or not? Cannot hear, louder. Louder, please.
I don't buy
Can you hear? Can you hear from the back? Can you hear or not? Cannot hear. Louder, sorry. Slower and louder. Okay. I didn't buy a lottery ticket this week. Okay, very good boy. Didn't buy. The next one. Okay. Huh? B or say again. I bought a. Okay. So either I bought a lottery ticket this week or I won the $1 million jackpot. Next. Yes. So if you bought it, then you won it. Next. Okay, lucky you, you bought and won it. Next. Okay. Very good. Must buy to win. Next. Yeah, if you didn't buy, then you didn't won. Didn't win, sorry. Didn't win. So it didn't win. Didn't win, huh? So after the past tense, you don't put past tense anymore. Grammar class. Next, G. G. Who is G? Ah, yeah, next. Okay, yeah. Yeah, I didn't buy and didn't win. Didn't win, sorry. Didn't win. Next. Okay, either you don't buy, or if I buy, if you bought, then you win. Okay, any question? Okay. Okay. Okay, next. Next. Okay, next. Okay, this row. Determine whether each of these conditional statement is true or false. So if 1 plus 1 equals to 3, then unicorns exist. True or false? True. Why? Okay, true because false implies false. Okay, because 1 plus 1 is not equal to 3, and then unicorn doesn't exist. So how do you know unicorn doesn't exist? Okay, we assume unicorn doesn't exist. Okay, in this class. Outside this class, I don't know. Okay. Next, if 1 plus 1 equals to 3, then dogs can fly. True or false? Why? Very good. False implies false. Dogs cannot fly. I think dogs cannot fly. There's no way. Okay, next. False. Why? Because dogs can fly. Can fly. Okay, dogs can't fly. And then true implies false is false. Next. Okay, it's true because 1 plus 2 is equal to 3. So I don't really care whether 2 plus 2 is 4 or not. Okay. Okay. Yeah, that's right. So I don't really care 2 plus 2 is equal to 4 now because I just only care 1 plus 2 equals 3. Okay. Continue next. Hey, wait. Maybe choose this row, this got no question. So I can start from the fourth. So state the converse. If it snows tonight, then I will stay at home. What's the converse? Okay, if I stay at home tonight, then it will snow. This is the converse. Okay. If going too fast, please stop me, okay? Feel free to stop me. Okay, next, what's the contrapositive?
If it's not
Okay, maybe we will say if I do not stay at home, then it wouldn't snow tonight. It won't snow tonight. So the wheel we will keep it on at the back. If I do not stay at home, then it won't snow tonight. Next. What's the inverse? I don't stay at If I don't stay at home, this is the contrapositive. What's the inverse? Inverse. Okay. So if it doesn't snow tonight, then I wouldn't stay at home. If it doesn't snow tonight, then I wouldn't stay at home. So maybe you go out and live there. Okay, next. Yeah, very good. If I go to a beach, then it's a sunny summer day. Okay, I don't have this. If I go to the beach, then it is a sunny summer day. So the previous class, there's a one student asked me whether we need to use whenever or not. I think it's a good practice if you use the same logical term. So if you use whenever, it will be, it is a sunny summer day whenever I go to the beach. Or you have to go, or whenever you go to the beach, it will be a sunny summer day. Right? Okay. I think you know what I mean. Go to the beach. Okay, next. Contrapositive. If you didn't go to the beach, then it is not a sunny summer day. Okay. Next. No. Because this whenever this is the P part, this is the Q part. Okay. So inverse is not P implies not Q. Repeat again your answer. Yeah. I didn't go to the beach whenever it's not a sunny summer day. This is the contrapositive. I want the inverse. Inverse. Yeah. It is not a sunny summer day whenever ever. If it is not a sunny summer day, don't use if and whenever together. So if it is not a sunny summer day, then I don't go to the beach. Okay. So just keep an eye that whenever here is a if. Okay. So actually this is the P part. Okay. So this should be a if here. This is the equivalent to if. Okay. Okay, next. When I stay up late, it is necessary that I sleep until noon. So what is the P part? Stay up late. Sleep until noon is the Q part. Okay, so what's the converse? Next. Oh, very good. Okay, you follow the structure as well. Next. Contrapositive. Next. Wait. Contrapositive again. Contrapositive again. Say again, say again. When I do not stay up late, it is necessarily that I do not sleep until noon. So this is the inverse, right? This is not the contrapositive. This is the inverse. This is the inverse. So what's the contrapositive? Mhm. No, it is not necessary. Wait. This is different. It is not necessary that I stay on it. Huh? It is necessary that I do. Yeah. It's different. It is not necessary that I stay out late, and it is necessary that I do not stay out late is different. Okay. You know the difference or not? Yeah, different. Okay. So inverse, we already say just now, right? Or want to repeat next one? Maybe just repeat it. So what's the inverse of C, 30C? Next. and you repeat the same mistake as the first at the in front then. Don't put the not in at the okay. I want to clarify this. Okay, I clarify this. Okay. It is not necessary that I stay out late. Stay up late. It is necessary that I do not stay up late. Okay, see whether these two are the same or not. So you see, so it is necessary that I do not stay out late. What does it mean? So it is necessary that I do not stay out late. Okay, so you do not stay out late. Okay, you do not stay out late. So the first one is what? It is not necessary that I stay out late. So it is not necessary that I stay out late. So maybe you still stay out late. Maybe you not. Okay. But it is necessary that I do not stay out. That means you do not stay out late. Okay, so these two are different. Okay, make sure you put the not at the right place. Okay. So not necessary, that means you either stay out late or either you don't. I don't know. But if I say you necessary, you do not stay out late, then you don't. Okay. So these two is different. Okay. Okay, next. Okay, next. Shout the answer for me, 48A. Anyone got the answer? 11000. Okay, check your own answer, whether you got 1100 or not. B, 01101. Good. C, 11001. Good. D, 11011. Yes, correct. Okay, check. So you do the thing in your bracket first, and then okay, last thing I want to say is this in the other class they asked me about how to read this. Okay, how you read this depends. So you have to tell me how you bracket this thing first. Or either you bracket in this way, or either you bracket on the other way. So either you do this and then do the whole thing, or you do the front part and then you do the whole part. But we will see later in the algebra of logic, they turn out to be the same. And this called the distributivity law. Okay. Okay, any more question? No more, then we dismiss. And then see you next week. Okay. Thank you. Bye. Thank you. Yeah. This is the thing. Okay, let's check this. Q is a necessary condition. So what is necessary is the Q. Okay. Yeah. Okay.